Absolutely, yeah, it'd be my pleasure. So thanks everybody for having me virtually in Singapore. I wish I was there in person, but I'm calling you from Colorado, where the headquarters of Digital Globe is. I think as Epi briefly alluded, I founded a company called TomNod, a startup based out of San Diego, where our mission was to crowdsource satellite imagery, crowdsource the analysis of imagery. And about a year ago, we joined Digital Globe, partly because now I get to drive 5 satellites in space, which is pretty sweet. So for those of you who don't know, Digital Globe is the world's leading provider of commercial satellite imagery. And since 1999, we've had satellites in space orbiting the Earth, taking images that if you've ever looked at your house on Google Earth, or you've ever used your iPhone to navigate to a friend's party, you've probably seen our satellite images. We now have 5 satellites in space, and they are collecting a lot of data all the time. So right now, our archive is up to over 4 billion square kilometers. So just to put that in perspective, that's more than 8 times the surface area of the Earth. So this huge image archive, tons of data, and kind of like a time machine for the planet, going back in time where we can see what's been happening over the surface of the Earth. So that's the volume, but let's talk about the velocity. Every day, these 5 satellites collect about at least another 2.5 million square kilometers more. So to try and give you some context for that, that's equal to the land surface area of Western Europe. So think for a minute, if you will, about every olive farmer in Spain, or every ship that's navigating the coast of Italy, or every car on the German Autobahn, or every green field in Ireland, or even every couple kissing on a street corner in Paris. All of that activity is happening all over the planet every day, and our satellites are capturing all of those pixels and getting this amazing view of the Earth. But the challenge that we find is, how do we understand what that tells about the planet? This is great to have all these pixels, but the current best solution for analyzing all of that imagery is the human brain and our eyes, right? Looking at all of these pixels and trying to decipher what's going on and what does that tell us about the Earth. And so I think this is a theme that I'm sure you guys are talking about all week here at Crowdsourcing Week, that the human brain conceptual capabilities are really unparalleled. I have a PhD in machine learning, and I can tell you that teaching computers to solve problems like this is really, really difficult and doesn't work well at large scale. But the problem with people is they're expensive and they're slow, and there's not that, you can't get them to do what you want them to do. And so that's where crowdsourcing comes in. So what if this guy, instead of trying to analyze this huge satellite image by himself, what if he had some help? Or what if he had lots of help? So this is the idea behind TomNod. TomNod.com is a website you can go to right now, or maybe just wait till we finish the talk. And it's a site where you can view satellite images and help us by telling us what you see in those images. And we use every voice of every person in the crowd, we gather it together and figure out where are the most important locations in all of these Digital Globe images. Now, as I'm sure everyone knows, you don't want to trust every random person on the internet. And that's kind of one of the challenges with crowdsourcing, is how do you extract that reliable insight from all of the people who are contributing to your crowdsourcing challenge. And so that's where we developed this algorithm that we call CrowdRank. And the idea is to combine the consensus from many, many different people all looking at these images, little parts of these huge high-resolution satellite images, to combine all of their inputs and sort of figure out not just the most important locations, but who in the crowd is reliable, who's always at the center of every cluster, who's the one that everybody always agrees with. And then conversely, who are the ones who are unreliable, who maybe have never seen a satellite image before, don't really know what they're doing, or maybe even deliberately trying to spam us. So using CrowdRank, we can take inputs from thousands or even millions of people, looking at billions or trillions of pixels, and figure out where the most important locations are. And so just to give you kind of a very high-level example, we're able to take an image like this, and this, in case you didn't already guess, this is actually a shot of Moore, Oklahoma, taken last year, just the day after a huge tornado swept right through the middle of the downtown. And as you can see, this scar across the land in the satellite image. Again, this is a very zoomed out view. Our Digital Globe imagery is actually, when zoomed all the way in, 1 pixel in the image represents 0.5 meter on the ground. So it's very high resolution, and sifting through every single pixel is a huge task. But within just an hour of getting this image, we were able to turn this picture into something that looks like this, where now every orange dot on the image represents a damaged house that was tagged by tens or hundreds of people to say, I think this is a damaged building. And the blue dots are places where roofs were damaged and tiles were stripped off the roofs. So by using a large amount of people, we were able to kind of extract this information from the pixels. So one of the cool things, I mean, this has many applications, helping the Red Cross figure out where they should prioritize their aid, helping insurance companies estimate the amount of damage that's been caused, and all sorts of other stuff. But where else can we apply this crowdsourcing idea? So we're responding to almost all of the major natural disasters around the world: earthquakes, floods, fires, storms. The backdrop you see here is an image from Tacloban City taken the day after the typhoon completely decimated that town, and we had thousands of people helping us map all of the damage. There's a lot of commercial and environmental impact as well. We can use this technology to map oil slicks on the water, to count even oil reserves in tanks, or map cars in parking lots, and all sorts of financial data that can be gathered. We use it to detect vehicles and human activity. So the image on the left is one of my favorite digital globe satellite images that's captured of the cruise ship Concordia after it capsized off the coast of Italy. Pretty amazing shot that you wouldn't normally expect to see from space. And maybe we can even use this technology to try and find missing ships, people, or planes. And so that's where our search for the recent, I'm sure everybody in the audience doesn't need to be told about Malaysia Airlines Flight 370, but the question in everyone's mind for the last month has been, where is its plane? And so one of the ways that we try to answer this is using TomNod. So if right now you go to tomnod.com, this is what you'd see. On our website, we're asking people right now to help us search satellite images and look for any evidence that we could find, any clues that might lead us to locate the missing Malaysian Airlines flight. And in particular, we're asking people to look for things like oil slicks. So maybe the presence of oil on the surface of the ocean could tell us about where a plane might have crashed. Obviously, any evidence of wreckage floating on the ocean would be a really important clue. Life rafts, or anything else that might be a clue that would help the search teams narrow down this enormous search area that they're having to look for to try and find the missing airplane. So how does it work? Obviously, you can just go to tomnod.com and try it out for yourself, but let me give you a brief overview of how it works. When you go there, you'll be beamed down right into the full resolution version of a digital globe satellite image, and we have many hundreds of these images up on site right now. So this is what we're seeing right now is a high resolution, 0.5 meter per pixel image of the Indian Ocean. And as you can see, there's whitecaps and waves and all sorts of stuff. And anyone who's ever used Google Maps before will be easily able to navigate around this interface. It's very simple. You can kind of guide yourself north, south, east, or west. And say if I go to the east here, and I see something that looks a little bit suspicious over here. I don't know. I'm not an imagery expert, but this kind of looks like out of place and surprising. So I can select one of the tags up in the top left. In this case, maybe I think it might be some evidence of the wreckage of the airplane. And I just click on that location in the image, and I've recorded my vote. So this is me as a non-expert person who maybe just found a link on Twitter or heard about it from a friend on Facebook, following this link and coming to TomNod and inputting my perceptual knowledge about what I see in this digital globe satellite image. Now, do this 100 or 1,000 or 1,000,000, or in our case, 15 million times, and you start to see some interesting consensus emerge. And so we've been applying this to hundreds of digital globe images collected all across the possible search areas for the missing airplane. And as everyone knows, the kind of information about where to look has been changing as the days and weeks go by and new information comes in. First of all, we were looking in the Gulf of Thailand, just north of Malaysia, where we thought the plane might have gone down. Then new data came in to say, well, maybe it's in the Straits of Malacca or even further west of that towards Sri Lanka or the Maldives. And then after the Inmarsat data came in, we kind of completely revised the search area and said, well, we need to be looking in the southern Indian Ocean off the coast of Australia. And so since that information came to light, we've collected hundreds more digital globe images where people have been searching through every single pixel and counting and marking everything that they see. Our CrowdRank algorithm consumes all that information and figures out the most important priority locations that we then send to the search teams in Australia, the US, and Malaysia. So here are a couple of quick statistics. We've had a really, really, really amazing response from the crowd, and I'm incredibly grateful to everyone who's participated on TomNod. This has far exceeded any campaign that we've run before. In the last month, we've had more than 8 million people come to visit the TomNod website. I'm not sure about this, but I think this may be one of the largest crowdsourcing campaigns ever. Of those 8 million, almost 1 million of them have actually signed up with their email addresses, which is really cool because not only are they helping us search for the Malaysian flight right now, but in future, when we have a new campaign to respond to a new event, we can call on this crowd and ask for their help again. The crowd has done an amazing amount of work. So of those maps that I showed you before, where I just kind of quickly flicked through 2 of them, we've had more than 775 million map views like that. Every single pixel that we've uploaded has been looked at by more than 50 people, which is really a phenomenal amount of crowd consensus that we're gathering over all of these locations. And in all of those pixels, we've collected more than 15 million tags. Now, obviously, there are not 15 million MH370s in this imagery. In fact, if there's one, we would be amazingly lucky. But using our CrowdRank algorithm and then expert image analysts who feed off of this data, we're able to prioritize this huge area down to just the locations that really matter. So we've actually managed to go through almost 1 million square kilometers of digital globe imagery. So just a huge amount of pixels that people have looked through in amazing detail. And a little sidebar that I think is kind of cool, it costs us about 80 grand on our Amazon EC2 account. So again, this is something that 5 years ago, without cloud computing, without the way that people are now connected online, this simply wouldn't have been possible. Of all of those millions of people who've come, one of my favorite people who've joined the crowd is a whole front woman, Courtney Love. And she actually sent a tweet about a TomNod image that she was examining, which she thought she'd found the missing plane. I always hoped to be written out in Rolling Stone, but I didn't think it would happen this way. So here's the image that Courtney saw. And I know that maybe the resolution might not be the greatest as we're connecting over online here, but if you give it a second, hopefully it'll resolve. And what you can probably see here is all sorts of kind of speckled across the ocean here, and then one kind of larger object here in the middle that could maybe be a field of debris with perhaps part of the fuselage sitting in the middle of the ocean. So Courtney tagged this along with hundreds of other people on the TomNod website, and this was sent to our expert analysts for review to figure out, is this really evidence of the missing plane? So, like I said before, you don't want to trust any one person in the crowd. When you start to see consensus, that's when the alarm bells go off, and you say, we need to send this to somebody who can really confirm or deny that this is actually interesting. So we gave this to our digital globe imagery analysts. These are people with many, many years of experience working with satellite imagery and doing analysis of this kind. And they were able to enhance the image, to zoom it in, to do some spectral color balancing. And this is what they kind of turned it into. Where now you can see that the speckles on the ocean are actually the wake coming out from the back of what seems to be a boat traveling through the water. So unfortunately, this one was debunked and it turned out to not actually be the missing plane, but it was able to direct our expert brains to a location that was actually pretty interesting. We've had many, many, many similar detections like this. This is another one that I thought was interesting, which again, in the TomNod high-resolution digital globe image, you see a long, narrow shape, kind of red color, that could perhaps be part of the fuselage of a plane. But once again, after our analysts were alerted to this location and they did some enhancements, we were able to determine this is probably more likely to be a boat as well. So the search continues, and as I said, thousands and thousands of people are searching on TomNod every day. And what they're producing is obviously a huge response for this MH370 search, and we're really grateful, and we'll continue looking until we find some resolution to this story. But thinking a little bit bigger, the power of this crowd, of having 1 million people to look at amazing images of our changing planet and figure out, locate every car, every ship, every person, every new building, every crop, every piece of information that's happening about our planet, is building a big data problem. But it's not just a big data problem, it's geospatial big data with what we're calling it. So gathering all of these layers of information together, images, pixels, open source data like OpenStreetMaps, machine learning algorithms that analyze every pixel, and then this huge human computation network that is crowdsourcing, we're starting to understand things about our planet that really, at a scale that was never really possible before. So that's kind of my vision for TomNod and for Digital Globe, is to take the power of this crowd and to really use it to crowdsource the world. So that's all I've got for you. Thanks a million for your attention. I hope you're able to hear me and see what I'm talking about, and I'd be very glad to take any questions that anybody has.
What do you give back to the crowd? How do you keep growing the community if there is no disaster?
What we've been seeing, we've been getting literally thousands of emails every day from everybody in our crowd. Everything from, I found it, you got to check this image out right now, like the kind of Courtney Love one, to your website sucks, it needs to do this, it needs to do that, all of these different bits of feedback. And what we're finding that people are getting out of this is a sense of kind of contribution, a sense of them being part of the solution to these problems. We see this with natural disasters, where people are all the way on the other side of the earth. They can't drive their ship through the Malaysian Sea. They can't fly an airplane or be part of the Australian Navy in search with a ship. But by going on Tomnot and looking at these images, they actually can contribute something meaningful. And so that's, I think, one of the biggest ways that people feel like they're getting something out of this. Obviously, we've built the website to be fun and engaging to use. You kind of can see your score and your ranking, how many tags you've placed and how many people have agreed with you. And we're always building out more of these kind of social and gamification features. People enjoy that. But I think really it's that feeling of being part of a mission that's bigger than just themselves, that has a kind of a global significance, is what we're seeing.
So in this case, price, it is not just a monetary. And this is what we're trying here to bring this understanding that when you think about crowds, they don't just get moved just because they see the monetary reward, but they get moved because they see there's this element, there's association, the intrinsic value that they get out of it. So it's very important to understand that.
I've talked a lot about, it's amazing how in a situation or a crisis like this, you can get a lot of people motivated to actually participate. I think a lot of people that run platforms, though, have a challenge in terms of curating what they have come back in terms of this fire hose of information. If you had to hire oodles of new employees or temporary people to actually, ferret through what you're finding out on your end in terms of making sense of what's coming back in?
Yeah, that's a great question. That's always, I think, the big question mark about crowdsourcing. If you go and stand up in front of, an intelligence director of a U.S. government intelligence agency and say, hey, you know what? You should outsource your spying to a bunch of people, random people on Facebook. You'll get laughed out of the room. And believe me, I have made that presentation and I have been laughed out of the room. But that's kind of where we try to bring in these things like the CrowdRank algorithm, where we're now statistically establishing consensus, right? If you have 100 people all over the world all looking at the same image and all saying the same thing, even though they're not in any way collaborating or colluding or in communication with each other, that tells you something. It tells you that the pixels are triggering some signal in many human brains that makes it seem important. And so by using CrowdRank, we can kind of capture that in a statistical way that says, with some sort of probability, I think here are the important areas and here are the areas that you can disregard. And so in many cases, that's the really important thing. We're not saying, go drive all your ships to this random location in the middle of the ocean, but we're saying, if you have a ship and you have to drive it somewhere, here are the top 100 places that I would consider. And we provide that information to those experts. And so we've been collaborating with both our own internal experts who've been doing this kind of work for years, who are experts in satellite imagery analysis, who can tell, a white cap from a ship or a ship from an airplane. And they help us do some of that kind of vetting, that QA process. And then we also provide that data, those kind of tips to our customers, like, for example, the Australian government, to help them prioritize. They are the ones who are faced with that challenge of saying, well, I need to hire 100 guys to go and look through all these satellite images and deal with all of this information and try and extract something meaningful from it. But by using the help of 1 million people on Tomnot, they can sort of shortcut that process and just say, well, here are the top 100 places that Tomnot sent me today. Let me figure out which ones I need to do or where I have people already on the ground at that location. So I think that's been a big part of the process. There is another kind of thing that we're currently prototyping, which I think is kind of this next wave of crowdsourcing is, we've got that first wave of information that comes through Tomnot, where that 1 million people pour through all those billions of pixels and tell us what they see. And then you get that kind of top 1% or 0.1% of the results out. You can actually crowdsource that again. And that's what we're working on right now, saying, well, let me go and reach out to just those top performers in the crowd and ask them for their expert review on, are these 100 top locations really important, and can you narrow that 100 down to just 1 or 2? So that's kind of the next wave where we're taking, this happens in Wikipedia, right? Random people write articles, but then you have this next tier of editors who can kind of really go and corral that crowd data, and you're kind of crowdsourcing the crowdsourcing. It's a bit meta, but I think that's kind of where we're headed right now. So there's a bunch of processes like that, from experts, algorithms, to kind of internal crowds who are helping us make that QA process scalable and actually work.